Hello and welcome to Sudoku. Here is a Set Sudoku puzzle that was featured in the latest Sudoku Grand Prix. It was organized by the Netherlands and the setter of this puzzle is Wilbert Zwart. And with 92 points, it was one of the two highest pointers and probably amongst the most difficult. I know that many very good solvers struggle a little bit on this one. Well, it took me some time to solve during the contest, but I'm not a top solver. Okay, so the rule is that every one of those cages has a sum, like in Kira Sudoku, but the sum is not given. The only information that is given is that all sums are different. And the first thing you should notice is that the minimum sum is 3. Oh, sorry, I put that in blue. The minimum sum possible is 3 with 1 plus 2, and the maximum sum is 17, which makes exactly 15 different sums, and there are 15 cages. So the rules could be rephrased as every sum between 3 and 17 should appear exactly once in those cages. Now, where do we start? Well, there are quite a number of given digits, so let's focus on classic Sudoku to begin. 7, 7, there's a 7 here. 8 is in one of those, and 4 is in one of those. The remaining digits in the box are 1 and 9. So we know that this sum must be either 9 or 17, and the other will be 5 or 13. 2, there's a 2 here. Oh, there's something about 1. 1 is in one of those. 2 is here. And 3 is here. Then 2 is in one of those two cells. 1 is here or there. And there's a 1 here, only placed in this column. The remaining digits in the box are 3, 4, 4, there's a 4 here. And the other digits are 3, 8, and 9. So the possible sums here, don't have a lot of room. So the possible sums here with 3, 8, 9 are 4, 9, 10. And 3, 8 or 9 here as well. 5 is not here, 2 is not here, 2 is not there, so we get a 2 here and a 2 in one of those two cells. 7 is not here, so 7 has to be down there. 5 is not here, so 5 has to be there. Actually, it has to be here precisely. And let's note that 3 on this row can only be here, so we get our first sum, 8. So I think we should keep track of which sums have been found in the grid. And now note that 9 is not here either, so 9 has to be in there. And we get an 8-9 pair, meaning that the 17th sum has been obtained. And then this is now 4 and 1, and with this one we can put them this way, and the sum 5 is in the grid. So let's remove this. Oh, sorry. I deleted the 17 in my book. Oh, so the remaining digits here are 5, 6, and 9. So the possible sums here are 11, 14, and 15. 5 and 6 are not there. 7 is not here, so 7 is here. And 5 is not here, it could still be here or there. But the possible sums are big here. With 5, 6, 8, or 9, it could be anything, well, no, not 14, sorry. It could be 12, 13, 15, or 16. That's a lot of possibilities. Not that interesting. 3 and 8, this cell is 4 or 9. This one is a 1. 6, 7 is not here, so because of this 7 we could place this 7 here together with a 9. So 16 has been obtained, and 16 is not possible. This is not a 9. So this one is 5, 6, or 8. This one is 6, 8, or 9. And then we need a 2 that's already been marked. We need a 7 here, which is in one of those two cells. And then this 9 is not available in this cell, so only 4 and 9 remain as options for this. And this is also 3 or 8. 7 is in one of those two. We still need, in this column, we still need 2, 4, 7, and 9. Well, that's a lot of options. And in this column, we still need 8 or 9, and 2 and 3. 8, 9 here, so this one is 2 or 3. Okay, where do we look now? Well, as I mentioned earlier, I solved this puzzle during the contest, but I haven't had a look at it since. Here I need 2, 4, and 9. Because of this, we get 4 or 9 here. 2 or 4, but 4 is not available. It would repeat the sum 5. So this one is a 2. And 3 is there. 4, 9 here. And this 2 tells us that 2 goes here. Here we need 3, 5, and 8. 1, 1, 1, and 1. There's a 1 here. So what are the candidates here? We know that 4 won't work because 5 has already been obtained. So 3, 8, 5, and 9. Well, that's a lot of possibilities. But 4 is not here. 4 is in one of those two other positions. In this column, I need a 1. Oh, yes, it's already been marked here. Something we should ask is, as we've seen, we've had quite already 2 sums with the 1, and at some point we will need the sum 4, which is 1 plus 3. It could be here, it could be here, but it couldn't be with any of those ones, because then the 3 would be in this block and 3 is already there. So I think the only possible places to get a sum of 4 are here and there, and therefore there must be a 3 either here or there, so there are no 3's here. And the fact that there is no 3 here means that in this column 3 can only go in this cell. Now there must be a 3 around here, not sure in which position. So we still don't know whether 4 is here or there. What about 15? Oh, I should remove 16 from this list. Sorry. What about 15? 15 could be here, 15 could be here. What happens? Oh, I was just considering. Oh, it's no. I was wondering whether there was a constraint that would lead to 15 here and there, but that's not possible. 5 would have to be in this cell, so this won't happen. So where should I look next? So here we still need 2, 4, 7, 9. I put in the candidates 2, 4, 9, 4, 7, 9, 2, 4, 7. I still need a 6 on this row. It's not here, it's not here. It could be here, it could be there. On this column, oh, this cell is restricted. 1, 2, 3, 5, 7, 8, 9. This cell is 4 or 6. And where will 6 go as a sum? Not sure I can deduce that. So let's have a look at this column. We still need 2. Oh, I was missing that. This 8 is not here. This 8 can only be here in this column. That's a 9. So this is not a 9. And now I know there must be a 9 here. So 11 is not an option. And there's no 9 in this one. And now those 3 cells are 3, 2, and 9. And the remaining cells here must be 1, 4, 5, or 6. 1 here. 1, 4, 5 here. 1, 4, 6 there. Let's have a look here. Oh. So what are the interactions? So this is 14 or 15. Nine is not here. 9 could go here to have a sum of 10. I don't think I've seen 10 in another cage as a possibility. Let's have a look at this column. We already have 4 digits in their places. We still need 1, 3, 4, 8 and 9. 8 and 9, so this is 1, 3 or 4. And what are the possible sums? Well, 4 wouldn't be with the 1 because we've already have the sum of 5. 4 could be with the 3, making a sum of 7. 6 could go with 1 to have a sum of 7, or 3 or 4, which is 9 or 10. And here, what are the options? So 1, 2, 3, 6. Oh, not a lot. 1, 2, 3, 5, 6. Only 4 and 7 can be here. That's interesting. So the possible sum, 1 wouldn't work. 1 plus 5 would, 1 plus 4 would be 5. 1 plus 7 would be 8. So 1 can't go into this cell. And this says that in this column 1 must be here. On this row 1 must be there. And now 1 plus 5 is not allowed. So this is a 6. So we now have the sum 7, and this is 4, and this is 7, and this is 2, and this is 3, and this is 9, and this is 2. So a lot is happening right now. And because of this, this cell has a 7. So a lot has been happening in a short time. And in this time, we got the sum 7 and the sum 11. So now we must... Oh, there was no 11 anywhere, actually. Okay. Now, this should really help us advance, move on. Here, the missing digits are 4, 5, 8, and 9. 4 is not allowed here. 5 works. 8 works, but 9 won't work because it's already here. So this is 6 or 9. Both are still possible. But here we have a 5-8 pair. And in this row, we know that 4 is not here because of this 4. And because we've already known that it's not possible, so 4 has to be here. And this is a 9. Now here we get 3 and 9. That's it. Here we need 5, 8, and 4. 5 is not here. That's not a 1. And this is not a 5, so it has to be 4, 8, or 9. And then here we still need a 6 somewhere. It's not here, so it's down there. This is 4, 5, or 8, but that's not the most important. 4, 5, 8, those are also 4, 5, or 8. And I see no other constraint. So what are the possible sums? Oh, none of them have appeared yet. 9, 12, 13. But look, this 6 is not here. So we can remove 13 from the options here. And what else can I see? I think the question is now, where will 10 be? I'm raising this question because 10 does not appear in any... Oh, yes, 10 is an option here. 4 or 10. And 10 wouldn't work here because 1 and 9, 6 and 4 are both forbidden, are both impossible. So 10 could be here or there. 7, oh, 7 is here. Oh, yes. Oh, 10 was an option for this. So 10 is no more an option for this, so 10 can only be in this cage. Yes, that's true. 10 can only be in this cage, so that's a 9, that's a 3. And now we have our sum 10, and this 3 gives that. This 9 gives this as a 5, with a 9, the 6 up there, and we get the sum 14. And to be fair, 14 seemed to be impossible elsewhere. Oh no, 14 could have happened here. Now this 9 gives this 8, this 3, this 6, we get this 8 as well. So we get the sum 15 and the sum 4. We got this 3, 4. So what remain? We still need 6, 9, 12 and 13. And 6 can't happen here. 6 can only happen here. So that's done. And now that we get this is 4 or 8. Oh, this 5 could rule 5 from this out for ages, and this 5 as well. Oh, not ages probably. So this down there is a 5. So now this is 4 or 9. So we know that the sum 13 is here. We've located the 13, so this one is not 13, it's 9. With 4 here, 8 there. And now this 8, you see, it creates what's commonly denoted as a deadly pattern with those 4 9s. But this one can't be a 17, it has to be the missing 12. And this resolves this small ambiguity. And we get an 8 here and a 3 there, which concludes the solve of this really challenging Set Sudoku puzzle by Wilbert Zwart. Challenging but fair. It could really be solved by patient study of what sums had already been used, what sums were unavailable, what sums had to be put in the grid. Thanks for watching this video. See you soon on Sudoku Canard.